Okay, today we're going to talk about limiting reactants, and we talked a little bit about that when we did the Lego activity on Friday. And with the Lego activity, we built different compounds and using the Legos, and they were each different colors. So, for example, you may have paired up a red Lego with a black Lego. That was your recipe, and you looked at all of your red and black Legos, and you decided to see how many of those you could pair up. And then you may have used up all of the red Legos and had black Legos left over, and you may have had it the other way. You may have used up all the black Legos and had too many red Legos. The point is that one of those colors, or one of the Lego pieces, you didn't have enough of to make your recipe work, whatever they gave you to pair together. And that's what a limiting reactant is. It's the thing you do not have enough of. So before we take some notes, let's look at the example, and we kind of looked at this last week too, where you made sandwiches. And we had a recipe for a sandwich, and with my sandwich I'm just going to have 2 pieces of bread and a slice of cheese. Now, what the recipe tells me is that for every 2 slices of bread, I have to have a piece of cheese in order to use up the bread and the cheese and to make the sandwich. So, for example, if I have maybe 6 slices of bread and 4 slices of cheese, here's what I can do with that. I can use my recipe and pair up as many times as possible 2 pieces of bread and 1 piece of cheese. Every time I do that, I'll get a sandwich. So there were 3 different times that I could pair up 2 pieces of bread and a piece of cheese. So I got 3 products here. But the thing is, I have an extra piece of cheese, this extra 4th piece. That's the reactant that I had too much of. The bread was all gone, so I have no more bread to react away or use up the rest of this cheese. So the bread is limiting the amount of sandwiches I can make because I have another piece of cheese, which my recipe calls for 1 slice, but I don't have 2 slices of bread to go with it. So the bread would limit me here. Cheese would be in excess or would be extra. All right, let's look at a different example. So let's say I have 9 slices of bread. Let me reset my recipe here. And then we have 4 slices of cheese. And let's add another one. So 5. Let's say I have this situation. So again, I'm going to pair up, according to my recipe, 2 pieces of bread and 1 piece of cheese. That will give me, if I pair all of those up, I can make at least 4 sandwiches. Now, I have a piece of bread left over, and I have a piece of cheese left over. So here's what we have to think about. We didn't use up everything exactly, but we have to try to decide, based on the recipe, which thing do I not have enough of. So I have 1 piece of bread, and I look at the recipe and realize it calls for 2 pieces. So in order to get rid of all of the cheese, then I have to make sure I have 2 pieces. So bread again is limiting me here. Okay, now, so sorry, I had to pause there for a minute. Anyway, we have here 1 piece of bread and a slice of cheese. So the bread was our limiting reactant. Let's go ahead and look at a real chemical reaction. So let's look at water. If I'm going to make water, water's formula is H2O. So I know I have hydrogen and oxygen that I have to put together, and the recipe for this is 2 of these hydrogen units and 1 of these oxygen units. So if I just add in some hydrogens and some oxygens, let's do 4 and 4. Here's how I can think about this. I know for every 2 hydrogens, I'm going to use up 1 of these oxygen units. So in my case, I have double the amount of hydrogens that I need. So I should be able to produce twice the amount of water since I have double of this ingredient. So instead of producing 2 waters, I should be able to produce 4, and that's the case. Now, since it only takes 1 oxygen, and I have more than double the amount of oxygen, I have 4 oxygens, that'll be left over. So in this case, you can see the hydrogen is all used up, so that's limiting me. There's no hydrogen left to react these oxygens that are here. So this is the excess reactant. So let's go ahead and look at this in terms of what you need to know for homework and things like that. This is the formal definition for a limiting reactant. And this little picture down here is kind of what I just showed you drawing or making water. So go ahead and write down the definition for a limiting reactant. You can add this to your notes. Okay, so limiting reactant, again, the thing you completely use up. Think of it like kind of the weakest link in a chain. It's the thing that you can't, you don't have enough of, it's not going, once it's used up, your reaction's done, so you can't make any more product. That's the thing that's going to hold you back. Now, the stuff that's left over is what we call the excess reactant. So things that you don't use up and you have too much of, basically. So here's the formal definition of excess reagent. Okay, so let's look at an example here with the hamburgers to kind of demonstrate excess reagent. I know I have, if I'm going to make a hamburger, I like tomatoes, so I chose this picture. So I know I need beef patties, I need hamburger buns, cheese, and tomatoes. And I'm guaranteed to make sandwiches because I know I have at least one thing of each of the ingredients. But in order to make a complete sandwich, I have to have one of each thing. So if I look, the lowest amount of ingredients type that I have are the hamburger patties. So I know I'm only guaranteed to make 3 complete sandwiches. Anything else is going to be left over. These leftovers, having extra of everything else, will guarantee that the reaction will happen, but it might mean that they won't get used up because I have extra of those. Okay, those are excess reagents. Those are the things, again, here for making water. Here, hydrogen, same picture as before, got all used up. Oxygen was left over. Okay, again, similar picture. We won't look at that. So here's what we need to think about. Here's what a problem will look like. So I'll give you a balanced equation. So go ahead and write this equation down and these 2 pieces of information. Okay, so here's what we have to do. We know we have this many moles. In chemistry, we count things in moles. So in the problems, like making sandwiches, we count things in slices. Here we're doing moles. So it tells me I have 0.202 moles of the phosphorus stuff, and that's represented here in the equation. And I have 1.56 moles of the oxygen. So and up here, that's represented as O2. So what we do to simplify these numbers a little bit is divide each number by the number that is the smallest. So in this case, I have 0.202 is my smallest number, so I will divide each number by that. So 0.202 divided by 0.202 equals 1, and 1.56 divided by 0.202 equals 7.2. Okay, so what this tells me is that for every 1 mole of the phosphorus stuff, which was represented here, I will need, in this reaction, 7.72 moles of the oxygen. That's the ingredients I've got. So it's kind of like if you're making a sandwich or baking a cake and you're looking through all your cupboard and the fridge for ingredients, and you take them all out and then you kind of look at them and decide what's the recipe and do I have enough of each thing and can I make this work. So that's kind of what we're looking at. We're looking at what we're given and deciding if we have enough. So here's what we're given. Now, from the equation, my recipe, it tells me for every 1 mole of the phosphorus, the P stuff, there's going to have to be 5 moles of oxygen. Okay? In order to make the reaction completely work, it's a 1 to 5 relationship. So 1 of these, then there's 5 of these. So let's take a look at how we can set this up. And go ahead and copy down this table. Right, we always want to compare what we have to what the recipe asks for. So here's our ingredients. We had the 1 mole of the phosphorus and 7.72 of oxygen. So, and on the recipe called for 1 phosphorus and 5 moles of oxygen. So now we look at the numbers and we ask ourselves, what do I have enough of? What do I have too much of? How do the numbers compare? So for I have 1 phosphorus that I need, and I have that. Okay, I have my 1 phosphorus, the recipe asks for 1. Now, oxygens, the recipe asks for at least 5. So every time I have 1 phosphorus, I have to have 5 oxygens. I have 1 phosphorus, and I definitely have at least 5 oxygens. I have more than that. I have 7.72. So in this case, I have too much of the oxygen. So if I wanted to react away all of this oxygen, I couldn't because I don't have enough of the phosphorus. So the thing that you have too much of, that's the excess reagent. The thing that I don't have enough of, that's limiting me. So based on the fact that I have too much oxygen, I can't react it all away with just this 1 phosphorus because the recipe only goes so far as to tell me that for every 1 phosphorus, I react away 5 oxygens. Okay? So, for your homework, and basically your in-class work, this should be turned in before you leave, or it's going to be checked and be stamped. This will be the last worksheet that will be put in your evaluation, and that's this one right here. There are 3 problems, okay? If you need to go back and replay any of the video, that's fine if I went a little fast on any points, but these problems work out exactly the same as the one in the video. This equation on number 3 wasn't balanced on the worksheet, but I will balance it for you here. And you can leave this up on the screen when I'm done, so you have it. Everything else, though, I believe is balanced, so you're good to go. Once you're done with the worksheet, the substitute will pass out the evaluation sheet. Your evaluation I will collect on Wednesday. When we get back, I'm not going to give you class time to search through your binders and things like that to get everything together. You can use some of the class time now to do that. The substitute has copies of each of the worksheets that you need and things like that, so you can compare and look for those now. So you can use some of the time to get that together, but do use some of the time to get some of these problems done, because these will be stamped for your progress to see how far you got before you leave today. If you have any questions at all, just shoot me an email or stop in and see me in the morning. On Tuesday, I'll be back. Again, we have ACT tomorrow, so good luck with that, and I will see you on Wednesday.